Let's begin. Today's May 12th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and uses the blue color for the verification cards. Let's go solve. So in our grid here, we've got our 6 criteria cards. The top row has criteria A, B, C. The second row has criteria D, E, and F. Criteria A looks at the middle digit, the square digit, and compares it to the number 3. Is square less than 3, equal to 3, or greater than 3? Criteria B looks at the third digit, the circle, and confirms whether it's an even or an odd. Criteria C takes a look at the whole 3-digit code and tells us how many 3s there are in that code. Are there no 3s, 1, 2, or 3? Criteria D compares the middle digit and the third digit. So it compares the square and the circle, and basically will let us know whether the square is less than circle, square equal to circle, or could the square be greater than circle. Criteria E takes the sum of the 3 digits, the triangle, square, and circle, adds them up, and confirms whether it's the sum is an even quantity or an odd quantity. And lastly, criteria F compares how the 3 digits are ordered. Are they in increasing order? Are they decreasing? Or do they just not have any kind of pattern to it? Okay, so let's begin with our proposal of 314. Remember, we're looking for a 3-digit code, each digit ranging from the numbers 1 to 5, and we're looking for that one unique code that confirms each of the criteria that we'll be determining along as we play. So I'm going to start off by testing criteria B and figuring out whether that circle digit is even or odd. Okay, so the Turing machine returns false. If I look at my proposal and I look at the circle, I chose a 4. The Turing machine is basically telling me, no, it's not an even digit in the code, so that means it must be an odd. So in my notes, I'm going to state that. So for criteria B, I'll be stating that circle is an odd digit. And since it's odd, that means I'm going to cross out all the evens. So crossing out all the evens, obviously that leaves me with the odd digits for the circle. Next, I'm going to test criteria E, and I'm going to take the sum and see if the sum is even or odd. So criteria E returns also false. So looking back at my proposal, if I add up the digits 3, 1, and 4, 3 and 1 is 4, 4 plus 4 is 8. That is an even sum. So the Turing machine is basically saying, no, the sum should not be even. So I'm going to go into my notes for E, and I'm going to state that the sum of the 3 digits triangle, square, and circle that the sum should be indeed odd. Is odd. Okay, so what else can we conclude by discovering that the sum should be odd? Well, I already have B be an odd digit, so that means that triangle and square must be not necessarily the same quantity, but the same type, basically meaning they're either both even or both odd. The reason for that is whenever we add two evens or two odds together, we get an even, and then an even plus this odd circle will make the total sum odd. So I'm going to add just a slight note here saying that triangle and circle triangle and triangle and square are both odd or even. Okay, so again, the reason is if you add two odds or two evens, that sum is even, plus the odd circle gives you a total overall sense that the sum is odd. So it doesn't necessarily mean that they're identical, meaning 1, 1 for triangle and square or 4, 4, but they've got to be of the same odd or evenness. Okay, so that doesn't really eliminate possibilities, but again, it gives us an idea of what the overall code is going to look like. Okay, so that's B and E. What can we do now? Let's see so again, we have two evens and an odd, or two odds and an even. We could test how many threes there are, but the potential, I already have one 3 in my proposal, so at least that would eliminate one of the possibilities. I could also compare square and circle. Let's see, what can I choose? All right, I think I'm just going to choose to count how many threes there are. So I'm going to do criteria C. Okay, fantastic. I think we really were very fortunate. So criteria C tells us, yes, there is one 3 in our code. So I'm going to go into my notes here in C and say there is 1 3-digit. Okay, so that's helpful going into the next round because we've already completed our 3 Turing tests. So now we have to come up with a new proposal. So we do have that 3 that we should keep. The question is, well, where does it go? Because at this point we haven't eliminated any 3s. So it could literally go anywhere. So is there anything in the criteria? Let's see, we haven't done A, comparing what square is to the number 3. We haven't done D, which is sort of comparing the square and circle. And finally, if they're ordered in a particular way. So the thing about square and circle, could they be identical? That's a possibility. With I guess that would mean that if they are equal, they would have to be odd, right? 1 1 3 3 5 5. Obviously, by eliminating the 2 and the 4 for circle, means that you can't have square be even. I don't know if that's necessarily helpful. So we're trying to figure out what these digits may be. How could we order this code? I'm kind of leaning towards maybe the square being the square being 3, and somehow circle being either smaller or larger than 3, and then somehow maybe forcing triangle, which we don't have a clue that specifically targets triangle. We obviously do have this some criteria. So possibly, I'm wondering if square is circle, sorry, if a square is 3, then, okay, so yeah, so let's think about this since I took this note down. Triangle and square have to be of the same type, even or odd. And so, let's see, how can we do anything? Circle's going to be odd. Okay, I think what I'm going to do, I'm just going to do 1, 3, 5. 1, 3, 5, and let's see, how far we get. Okay, so let me test criteria A. And so, okay, so that is correct. So 3 was a good, guess. So A, again, is comparing the square digit to the number 3. And it is true that square is equal to 3. So that's criteria A. So square is equal to 3. So that means that I can eliminate all the other square values except for 3. Okay, so this is interesting. So now notice that since circle is odd, right? We know circle is odd. That forces a triangle to also be odd. Okay, so remember that in our note here, triangle and square have to be of the same, even or odd. Since it's 3, that means I can eliminate all the evens for triangle. So it was indeed an all odd solution. Okay, so we have 3, and so now we can then compare square and circle. And so that would be criteria D. Okay, so that is incorrect. So it's not true that if I look at my proposal, square is smaller. So it's not true that square is smaller. So that means it's either equal or greater than circle. So in D, I'm going to say that square is either equal to or greater than circle. Okay, so if square has to be greater or equal, can we eliminate any possibilities? So it looks like circle cannot be 5, right? Because they're not equal. So I can eliminate 5. Okay, it can be a 3 because it's square and circle possibly could be equal. And that's it. So yeah, so we can eliminate 1 or 3 because they are both square is both or can be either greater than or equal to the circle. 3 is greater than or equal to 3, and 3 is greater than 1. So it was only the 5 that I could eliminate. And so we don't know which one it is at this point. The last criteria we haven't tested is F. And so let's take a look. And yeah, we'll just say, yeah, because I don't think we can test anything else. Everything else is pretty much set in stone. Okay, so let's just test F. Okay, so it is incorrect that it's increasing. So it's either decreasing or they're kind of mixed up. So I'll just type in a note here saying that digits are decreasing or have no order. Okay, so at this point we might just want to start listing out some possibilities. Okay, so so let's test this out. So we obviously know that the middle digit has to be 3 and circle is either 1 or 3. So it's triangle that gives us the most options. And so we really, this is interesting. We've already, I think, other than the criteria F and maybe D, we haven't really eliminated too many. I think there's still too many possibilities, but let's just go ahead and list them out. So we can have triangle be 1, square be 3, and circle be 1. So let's see, there's 3 on the top, 1 in the middle, and 2 on the bottom. So that means that there should be 6 potential solutions. So we'll just list them out. 1, 3, 1 is the first. 1, 3, 3. Okay, so that's the first one. The next one is going to be 3, 3, 1, and 3, 3, 3. And then finally 5, 3, 1, and 5, 3, 3. Okay, I think that lists them all. Again, there should be 6 because we got 3 possibilities on the top, 1 on the bottom, and 3 in the middle, 1 in the middle, and 2 on the bottom. So we multiply those quantities. 3 times 1 times 2, that's 6. That means that there should be 6 potential solutions. And just to verify, 1, 3, 1, 1, 3, 3, then 3, 3, 1, 3, 3, 3, and then 5, 3, 1, and 5, 3, 3. Okay, that looks like a complete list. Can we eliminate any just from what we know so far? We know that I picked the middle 3. That's correct. Circle is odd. Okay, so there's only 1 3-digit. So I can eliminate any potential solutions that have more than 1 3. So I can eliminate 5, 3, 3. All right, I can eliminate 5, 3, 3. I can eliminate the one that has all 3s. I can eliminate the 3, 3, 1. And the 1, 3, 3. Okay, so I was able to eliminate all those because we know that there should be only 1 3-digit in our answer. And all those had at least 2. So we're down to 1, 3, 1 and 5, 3, 1. So notice 1, 3, 1 has no order. It goes from 1 to 3 and then down to 1. So, there's no progression. Whereas 5, 3, 1 is a decreasing. And those are actually both of our last remaining sort of description for criteria F. So I'm just going to pick one, and I'll just do the opposite, 5, 3, 1, and see, and we're going to test F one more time. So 5, 3, 1, I'm going to test F, and it was incorrect. So it's not that 5, 3, 1, it's not the decreasing. So I'm going to go into my list of possible solutions and cross out the 5, 3, 1. And then I'll cross out the part that is decreasing here. So in fact, there is no order. Okay, and so again, based on the solutions I listed out and what I've eliminated, I end up with 1, 3, 1. So there was a duplicate, there wasn't a clue to tell us, but sometimes that happens. So let's just quickly review the 1, 3, 1 versus all our criteria. And so yes, we know that the middle digit has a 3. 1, 3, 1 does. We know that circle should be an odd digit. It is. It's a 1. There's only 1 3. That's correct. Oh, the one thing I guess we didn't conclusively, determine from the Turing machine is whether square and circle are either even or is square, equal, or is square greater than circle. So we're deducing that indeed it should be greater than, since 3 is greater than 1. Is the sum odd? It sure is. And both, triangle and square are the same type. They're both odd. That worked out. And they have no order. So based on that, I feel pretty confident. So let's actually go to the Turing machine and confirm our solution of 1, 3, 1. So let's test the code. 1, 3, 1. Verify. Okay, yes. So we got it correct. That's awesome. But our true test is how did we do versus the Turing machine. So let's go back, and so we did in the first term criteria is B, C, and E. So let's input that. So B, C, and E. C was the only correct one in that turn. And then we did A, D, F. We did A, D, F. And A was the only correct one in that turn. And we had one last turn, and that was to test F, and it was incorrect. So let's see how we did versus the Turing machine. Okay, we tied. So again, a tie means that, we won. So we matched wits with the Turing machine. Well, that's it for today. Please, if you do like this video and the previous videos, please give it a thumbs up so that others can be aware of our channel. And if you don't want to miss tomorrow's puzzle, please subscribe to be notified. Thanks again. Have a great one.